All right, everybody. Here's day one of our Chapter 5 unit where we're going to be talking about the parts of radicals and how to simplify things that are in that radical. So you're probably asking right now, well, what even is a radical? A radical is defined as basically taking the root of something. It's the opposite of a power. So the nth root of a number a can be written in the radical expression the root of a, and where n, this number n here, things that would fill in for n, we call those the index. That's our index. And we call it the radical because this check mark sign here, sometimes you'll see it as a square root, but it could be any type of root. We call that the radical. That is the radical sign. And the number that we have inside our square root, or any root that we might have, this a, for example, would be what we call the radicand. Now, sometimes though, we'll see this radical sign without any number in place of n. That's what we would say is not having an index. That means that we have a 2 there. We have that square root that I know we've seen before. So with that then, if a radical has more than one root, the radical sign indicates only the positive root. So only a positive number. So we know, for example, like number 1 here, we have the square root of 16. Well, there's 2 ways that I can get 16. I can take negative 4 times negative 4 or positive 4 times positive 4 to get 16. That means that I know that I want just the positive 4. So let's talk through, let's just list the first 12 perfect squares. The first 12 are 1, 4, 9, 16, 25. Now I'm going to pause there really quick. Where am I getting these numbers from? Well, the perfect squares are the numbers you get when you take a number times itself. That's what it means to be squared. So 1 comes from 1 times 1. 4 is 2 times 2. 9 is 3 times 3. And 16 is 4 times 4. 25 is 5 times 5. 6 times 6 gives you 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And our 12th perfect square, 12 times 12, is 144. So now we can go through and list some of these other perfect square roots here. You could do examples 2 and 3, but I'm going to show you 4 because it uses one of the numbers that we don't have on our list. So I have 3 times the square root of 400. And 400 is a perfect square. I get 400 by taking 20 times 20. So that means that this is the same as 3 times just 120. And 3 times 20 would give you 60. Now you could do the same thing for 2 or for 3. We're multiplying after we take the square root of our number. But the main thing that we want to talk about is what happens when we have a square root that isn't a perfect square. Well, there's 3 simple steps. First thing we want to do is find the largest perfect square that our radicand is divisible by. We want to list the factors. And then we're going to break down that radical using those numbers. The second thing we're going to do is take the square root of a perfect square and take it out of that radical sign. We want to get rid of that square root sign. And then we're going to leave the leftover piece inside the radical. I can't take the square root of a number that isn't a perfect square, so we're going to just leave it as it is. So for number 5 here, I have the square root of 32. 32 is not in our list. It's really close to 36, but it's not a perfect square. So 32 would be to say, I want to list those factors. That's my first step. So the factors of 32 are 1 and 32, 2 and 16, and 4 and 8. Now we would want to say whichever one has the largest perfect square, that's the factor pair that we want to pick. So we've got 2 and 16. we've got 4 and 8. So 16 and 4 are both perfect squares, but I want the largest perfect square, meaning that 16 is bigger than 4, so 16 is the largest perfect square factor of 32. So I'll write this as the square root of 16 and the square root of 2. Now the next step is to take the square root of the perfect square and get it out of the square root. We said the square root of 16 is 4. It's one of our perfect squares. And so instead of square root of 16, we would say 4. And we're going to leave that leftover 2 that we have in the radical. So I have 4 square roots of 2. That would be as simplified as we can go. I can't do anything else with 2. So now I want you to try one other example from 6 through 10 here. That's one of your problems that I'll have you come back and double check that answer with me. On the next page, we talk about what happens when we have variables in the square root. Now, when we have variables, there's 2 different options, and we're only looking at the square root. Now, if m is a multiple of 2, that's the exponent here on a. If it's a multiple of 2, then what we're going to do is we're just going to take our exponent and divide it by 2. Nice and easy. However, if we don't have a multiple of 2, we need to break it down into 1 less than the exponent we have and our extra a. And we'll take a look at that example here in a second. Basically what we're doing is we're trying to make it so I do have an even and that leftover piece, similar to our last examples we were looking at. We had that leftover factor that we couldn't take the square root of, and then the other part that we could take the square root of. So first, let's just take a look at 2. I think 1 I'll skip for now. If I take a look at number 2, I notice that there's a 9 and a variable. So I like to do the number part first. I see this 9, I'm going to write each part in its own square root. So I have the square root of 9 and the square root of k to the 10th. Now, hopefully you remember that the square root of 9 is a perfect square. The square root of 9 is 3. So I can simplify that. I don't need the square root anymore. I already took the square root of 9. I don't take the square root of 3 as well. But if I have the square root of k to the 10th, in order to get rid of that square root sign, I need to know, is it a multiple of 2 or is it not a multiple of 2? Is it an even number for my exponent or is it an odd number for my exponent? Well, for k to the 10th, 10 is an even number. So I would say that I have k to the 10 divided by 2. And once I write that divide by 2, I don't have a square root sign anymore. I'm going to get rid of the square root and simplify this 10 divided by 2. So I now have 3. K 10 divided by 2 would give me 5. I don't have any more square roots. I can't do any other multiplication or anything with this. So that is as simplified as that gets. Let's jump down, though, to number 6, where I have a few different examples here in this one problem for you. So for number 6, I have 3 variables, p to the 15, q to the 9, and r. So we've got a couple of variables in this one. So I've got a p to the 15, q to the 9, and r. So I'm going to write each of those in their own square root. This is always my first step, and you should try it too. Always going to write each one in their own square root sign first. Then what I'm going to do is I'm going to just look at each one individually. These are all multiplied together, so when I get my final answer, they'll all be multiplied together as well. For p to the 15, I need my exponent to either be even or odd in order to use one of these rules. And I know 15 is an odd number. It's not a multiple of 2. So I need to break it into pieces. Instead of being p to the 15th, I'm going to make it p to the 15 minus 1 and an extra p. So 15 minus 1 would give me p to the 14. And my leftover p goes in its own square root. Now, p to the 14, in order to get that out of the square root, I'm going to divide it by 2. And it's no longer in the square root. But my leftover p will stay in the square root. Now, I'm running out of a little bit of room here, so I'm going to just write equals over here because I know I'm going to have more work to write down. But if I take 14 divided by 2, I get p to the 7th, and I still have my square root of p left over. So I'm going to put that over here for now, and you'll see why in a minute. So I'm going to do the same thing with q and the same thing with r. Q is an odd exponent. 9 is odd, so I need to do the same thing again. I'm going to take 1 minus 9 will give me q to the 8, and then my leftover q. To get the q to the 8 out of that square root sign, I'm going to divide it by 2, and I'll still have my 1q left over, and 8 divided by 2 would give me q to the 4th. Now I still have this extra q. You might be asking, where do I put that extra q? Well, because it's in the square root, it'll go in our square root here with that extra p that we had. So I want to simplify this square root of r down. Well, r is tricky because there is no exponent on here, and when I don't see a number there, I know that it's 1. R to the 1 is odd, but I can't take 1 away to make it an even either, to follow our rules that we have up here for our radicals. So the only thing I can do with r is just like what I did with p and q. It just goes at the end of everything and gets written in to that radical at the very end. Anything that's left over in the square root that I can't take the square root of will all go in one square root altogether. Anything that's not in the square root will go in alphabetical order in front of that square root. So what I want you to do is I want you to take one of these examples here, and let's try 2 of these examples. So anything that I haven't already done, 1 through 12, give one of those a try, and those will be one of the ones you check in with me. All right, our last thing for our day 1 here is to combine radicals. So we want to simplify our radicals and then try and combine them. So we've got our 3 steps here. First thing is to simplify. So that's back to what we were doing before. Step 2 says to identify radicals with the same index and radicand. Those are the only things that can be combined. So they have to have the same type of square root, and they have to have the same number in the square root. That's the only way you can combine them. And anything that is common, you can add and subtract them just like you would normal numbers. So think of your square root as a variable. Now for our first example here, I've got -2 times the square root of 20 minus 2 square roots of 5. Now, if I were to write these using variables, this would be like saying -2y minus 2x. And hopefully you would all tell me that y and x can't be combined in any way, so I would leave it as it is. Well, thankfully, our variables are a little bit different. I can simplify my variable to see if I can't make it something that I can reduce down and actually combine. So in order to do that, we have to simplify this 20. So square root of 20, let's list the factors: 1 and 20, 2 and 10, and 4 and 5. Now we said when we simplify these square roots, I want to pick the biggest perfect square out of there. That would be 4. It's the only perfect square in our list. And 5 is its factor pair. So I would write this out: -2 square root of 4 square root of 5 minus 2 square root of 5. I would take the square root of 4, and we'll have -2 times the square root of 4. That's 2. 2 times 2 gives me 4, so that is its square root. And then times that square root of 5. That's our remainder that just tags along. And we've still got -2 square roots of 5. Well, -2 times 2 would give you a -4 square root of 5. And -2 square roots of 5, well, hey, now I have square root of 5 and square root of 5. That means that I can combine those two together because they have the same radicand, the same index and the same radicand. They're both square roots and they both have a 5. So -4 minus 2 would give me a -6 square roots of 5. Again, these are just like variables, so I'm not getting rid of the square roots of 5 when I'm adding or subtracting. I'm only looking at the numbers in front. I'm saying I have -4 of this thing, and I'm taking 2 more away. -4 minus 2 gives me that -6, and we're talking about square roots of 5. So we've got about 8 other examples here for your first day. Give one of these a try, any one of them, give it a try. You might want to try something like number 6 would be a good one, or number 5. Both would be good examples to try. But make sure you try some examples. Come back in, check in with me so that you are dismissed for the day.